Okay, today let's revise about the ray diagram. Three rules called KFC. KFC. Okay, so for the length, last time we already did this. Where is it? uh, uh, where? Hmm? 那个属 module physics 跟 SPM module SPM。太稀罕。Okay, last time we already draw this. Actually, the light always follow KFC. But when the lens and mirror change, the C also change. Okay, for example, convex mirror. 有这个吗？但是不是有诶？好。Okay, for convex mirror, how to draw a convex and concave mirror? Still remember? Cave means what? Yeah, 凹进去山洞。So cave is like this cave. Okay, concave mirror. Convex mirror is like this. Then concave lens. Yeah, I did very good. Yeah, convex is out. So imagine your eyes is here. Okay, so for concave lens, you can draw like this. Or we just use the bracket concave like this, convex like this. Normally we draw like this, but you also can use the bracket to show it is. It pops up. This one curve in. Okay, then we always draw KFC. Okay, what is KFC? Means when the light reach, sorry, I should say the C first. I should say the C first. The C is over here. Because for mirror, we count it as a circle. So the C is behind the curve. So the C now is in front of the curve because we count it as a circle. But for lens, the optical center always at the center of the lens. So the C is here. Okay, so now how to draw KFC? Okay, so we say K is like kotak from the object to the lens or mirror. So always draw the first one. Always draw the first one like this. Then to the F, KF, to the F means like this. But Actually, it's a mirror. It cannot form, the light cannot reach F. So normally we use dotted line. Then it will reflect. After that, from here, directly go to C. KF, C, 2 center. Ooh. Sorry, I don't have ruler. Cannot draw very perfect. Then, when these two light intersect, so here will be your image. Here is object. Here is image. Okay, then this one, KFC. Then it will extrapolate and then become here. So always remember, if you want to magnify an image, we use U smaller than F. The same thing here, this is a lens. So the light suppose goes through the lens. So it goes down, K, F, then C. So since they open, they diverge. So we converge them. So our image is here. Okay, then this one, K, this is lens. F, we use the F in front because it will diverge the light. But how much it diverge depends on the F before. A, F, C directly goes through C. So here is your image. So now look at page 201. Now look at page 201. Okay. A ray parallel the principal axis is refracted past F. So we say this is KF, 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 okay, KF. The ray that passed through F is refracted parallel to the principal axis. So we say this is FK. The light passed through F will go parallel. The light passed through F will go parallel after that. And C, no matter how, when the light passes through O means the center, optical center of the lens. The center of the lens is inside the lens. It's not refracted and travel in a straight line. Means when it goes through C, optical center C, it will go straight. It will not refract, so it will go straight. So we say this is KFC or FKC. Okay, so now look at this. How to draw the image. So let's draw KF. Use ruler, yeah. KF, then C. So this is object. Remember to label this is object, this is image. Image supposingly draw dotted line because it's virtual image. It's virtual image. What is the meaning of virtual image? Anyone can tell? Virtual, like VR, virtual reality. What's that? Virtual. Yeah, cannot form on the screen. Thank you, Bethany. Virtual means cannot form on the screen. Can form means it's real. So how to know it's virtual or real? Okay, so this is before the lens. This is after the lens, before and after. So the light, yeah, good. The light suppose pass through the lens and form here. If the image formed after the lens, yeah, it is real. But now, you see, the light form in front before the lens, so it's virtual. Means we cannot pose it on the screen like the projector. We only can see inside inside the lens. Okay, so now how about the size? Bigger, right? Bigger, what we say? We say magnify. Magnify. Image bigger means it will be magnified. And then how it's virtual, so normally it's upright. So when it is upright, it is virtual. Okay. So we say on the same side as object, so it's virtual. Because the light supposed to pass through the lens, but not. If I write bigger image instead of magnify, no marks. That one I'm not so sure. But I encourage you all use magnify. Okay, so now this one, same thing lah. K, F, F, K, F, C. Then you will find out it's parallel infinity. Same thing, K, F, C. So image form here. Same thing. Remember, draw arrow. Same thing, K, F, F, K, F, C. And you will find out the image form under 2F. Exactly the same size. Same size. When it is 2F, always same size. So before is always magnified. Magnified. So this one will be magnified too. Okay. Then, if form on the same side, sure is upright and virtual. So this one is also, you can see the ballet already. This one point up, object point up, image point down. Means it is inverted. Up, down, the ballet. Upside down, inverted. Then it's virtual or real. Yes, now it is real. Normally real is inverted. Because now the light passes through the lens and image form behind the lens, after the lens. Okay. So this one, because same size, so normally we use for photocopying machine. So whatever size you scan, then whatever size it will photocopy out. So this is same size. So after the lens, so it's real, but upside down. We don't say upside down, we say inverted. Okay, most of the time, this one will exist in paper one. They normally give you the words like this. Okay, same thing one. same as up one, but this one, the image form in infinity. What does it say? Blur. Infinity. Image in infinity. Not infinity means very far away. Image form in very far away. This one no need. This one no need extrapolate. No need because they already intersect. They already intersect here. So why we always extrapolate? Because they does not intersect. They does not intersect. So we extrapolate. If they intersect, no need extrapolate. See, they intersect, so no need extrapolate. Yeah, so this is object, this is image. Must label, right? So why the diagram is so important? Because if they ask for 4 marks question, I just draw the array diagram, you get 4 marks. No need to say anything. Okay? So now this one, the same thing, K, F, focus, A, F, C. C is the center of the lens. And you will find out it starts to become smaller. Smaller, normally we say diminish, diminish, diminish. And this is real because after the lens, because the light supposed goes through the lens. So normally it's inverted, real inverted. So normally this one is lens of camera. KFC only, KFC. So object, image. Okay, so now U in infinity means the U come from very far away. The light come from very far away, so the light will go through. So this one we use FKC. When the light goes through F, make it like 20 degrees. When the light comes from far away. So F, when the light pass through F, then it will become parallel K, like a botak. Then, same angle, we draw a line goes through C. Same angle, right? We draw the light pass through C. We draw the light, same angle, pass through C. And you will see the image will form right under the focus point. Right under the focus point image. Object from infinity. Apa itu? From infinity actually means more than 2f lah. Okay, more than 2f. Ta-da! This is just linear. Very cute. There. This one. Okay, the person very far away, but they form the image into the screen. This is diffraction of light. Wait a minute, one more. Okay, now this one. When the light comes from infinity, very far away from outside the window, this is the sun at that time. This is the sun at that time. Okay, and form upside down. Okay, so this is in the focus point. Okay, so now this one shows what? This one shows the object come from very far away from infinity. When it goes through the lens, the image will form on F. So you can see very clearly. And what is this? This is image. This is image formed on focal point. This is image formed in infinity. You will see very blurred. Okay. This is our, how to say that, cat's eyes. No. Our room outside of our room. Sorry, this is using concave lens. Concave lens. Concave lens means it will shrink the image, means diminish the image. You can see wider field of view. Wider field of view. This is magnifying glasses. This is image formed on focal point. It will diminish, but very clear. Okay, so now this one is image is diminish. Then object inverted. This is object real. Okay, so this is convex lens. Then how about concave lens? The same thing. KF, FKC. Okay, so but now concave lens, it will diverge. How much it will diverge? What is the angle it diverges? Depends on the focal length before or in front of the lens, right? So we use the focal point before negative f to determine what is the angle it diverges. So we say this is diverge line. Diverge 就是扩散它，分开的。So this one also the same thing. We diverge the line. We diverge the line by using the f in front of the lens. That's why we say it's negative f. And this one we use the f after the lens, so it's positive. Okay, now fk, you can see f goes through f, so k is parallel to the principal axis. When it goes through f, so after that, it will go parallel. So always remember kf, fk, c. We seldom use fk if just in case the object come from infinity, then only we use fk. Actually, you can draw three lines together. You'll find out the image always intersect on these three lines. Okay, then rule C. Go straight only, no refraction. Okay. So now how about this? Same thing, look. K. Because this is concave, so it will diverge. So how much it should diverge? How much it should diverge depends on the F here. Okay, K, this is K, F, and C is the optical center. Optical center. Okay, then where is the image? Image is the intersect of KF, C. Intersection of KFC. So this is object, this is image. So can you please tell me if the image now is magnified or diminished? Here, when the two light intersect, this is the image. Anyone can tell me now image is diminished or magnified? Thank you, Grace. Diminished. Diminished. Okay, so it's upright. And somehow it's in front of the lens, so it's protrude on the same side. Okay, and what is the application? We use the correct the short-sightedness. Okay. Okay, so normally, see, in this part, this side is curved inside out. If you are short-sightedness like me, it will curve inside, so it's concave lens. It's concave lens. Okay, then the peep holes in the door to see object outside the door. Okay, so image diminish got what kind of advantage? We can say we will have wider field of view. Or you just write wider view, wider view. Now, so you can see the peep hole. Now, you can see actually the object of the door outside, the wall outside is very huge. But now, since the image diminish, so we can see the whole thing. So we say this one can see wider field of view. Okay, wider field of view. So this is lens for magnifying glasses. You need to put the object. You need to put the object very close, shorter than focal length. All right. Hotel door. Yes, very good. Hotel door. In Malaysia, we seldom use the peephole. We always use CCTV. Okay, in Malaysia, we normally don't use peephole. We use CCTV. Closed circuit television. Okay, so together with convex lens to overcome aberration, which is a type of defect in lenses. Also, we can use as multifocal lens. Okay, some people, not some people, I might be the one. When I get older, I will get some long-sightedness, but I still have short-sightedness, so I need two focal length. Let me check if I have one. Okay, so this one, we call it as convex mirror. So same thing as concave lens. So same thing here. Convex mirror and concave lens have same image characteristic. So since the image diminish, so we can get wider field of wider field of view. The real shop is very big, but why we can see inside a small mirror? Because the image diminish. Okay, so done. So here we have the linear magnification. M equals to HI over HO. Linear magnification does not have units since it is a ratio. How much it magnifies or how much it diminishes. Okay, there's another formula is M equals to V over U, where V is image distance and U is object distance. Okay, HI over HO means height of image. Height of image divided by height of object. Actually, it's in your maths you learned before. K equals to PA prime divided by PA. Enlargement transformation. So how much it magnified? How much it diminished? So depends on the, okay, let's say your image length is 10, your object length is 5. So 2 times it magnified. So let's say your image is 2, then your object is 4. So now your K become what? Magnified. Linear magnification would be half. What does it mean? Object shrink, object diminish. Okay, object diminish. Okay, so what is image distance and what is object distance? Let's look back. Now, for example, can you see that? Okay, this picture. Can you see that image, this distance, image to the optical focal length would be U. Sorry, object to the optical center. This is image to the optical center, U and V. So you can see when it's further away from the center, it will be larger, no matter U or V. Okay. So this one, this is U, and in infinity is V lah. Okay, then how is it? How is it looks like? Nah, this one lah. Why you see it's blur? Actually, it magnify for too large. Okay, because quite far away. So always remember when it's further away, then it will be larger. Now, so for example, this is U. So U is in between F and 2F. Capital F is a point. The length is small letter. So now from here to here, this is image, right? So you can see image further away from optical distance, so it's larger. Now this one, the same thing. This is object to the optical center. To the optical center, it's U. This is the image. You will find out these two, U and V, is the same distance. So the height of object is the height of object will equals to height of image. Same size. Now this one also the same thing. This is height of object. This is height of image. So you can see V longer, height greater. Same thing here. This is U and this is V. So you can see U further. So height of object larger than height of image. So height of image smaller, diminish. Okay. So this one from far away means the object very, very, very large. So when it comes to here, this is V. U is from infinity. It's very far away. Okay, so let's try this linear magnification. So we say m bigger than 1 means the size of image is larger than the size of object. M smaller than 1, see, m smaller than 1 means image is smaller than the size of object. So we can get the linear magnification as m equals to v over u and also equals to hi over ho. And formula given or not, formula only give one. Only give one. Formula only give this. This v and this u means object distance, image distance, focal length, right? So now the length formula is using this. Refractive index not given. Depends. Depends. Sometimes if they want you to find I or R or C, yes, N is given. And then refractive index for different material are different. Okay. So what is real depth over apparent depth. Look at this girl. Apparent image. Yeah, thank you. This is total internal reflection. Can see that? Go straight. Go straight. Goes through parallel to normal, go straight. Then this one, the light away from normal. The light away from normal. Away from normal. And then when it reaches critical angle, it will be 90 degrees refraction. Means what? Means this is C. C is incident angle. Refract light in 90 degrees, critical angle. After that, it will reflect back, total internal reflection. And then from denser medium water to less dense medium air. Denser medium, less dense. This is microwave. How microwave heat up the water? Using the wave makes the water vibrate, turning. So the water will produce heat lah. So actually makes the oil vibrate. Microwave makes the oil vibrate to produce heat. Like friction will produce heat. Oh, by the way, drone, 无人机 drone. Normally, what wave we use to control the drone? Can guess? Is it radio, microwave, infrared, visible light, ultraviolet, X-ray, gamma ray? Which one? Guess. Thank you, Liang Zhi. Thank you, Aiden. Okay, infrared 1, radio wave 1, radio, micro, infrared, visible light. 随便猜一个。什么？卫星啊，卫星的是什么 wave？ Radio wave, infrared. Okay, actually answer is microwave. It's these two lah. Some they use radio wave, some they use microwave. Because microwave can penetrate through atmosphere. Sometimes a drone will fly too far away or too high away, so we use radio or microwave. Which one depends on the question? Now most of the drone they use microwave. Okay, why not infrared? Okay, let's see. This is my remote control. Here is the infrared. If you have any remote control, you just take it. It's to detect the movement, or not only that. Yeah, correct, infrared. And then infrared actually very easy to, we cannot see like this. Hey, come down, man. Okay, but see, if I press the button, So on the infrared only can be seen through camera. Okay, and then infrared is very easy to block. See, I put my hand here and I point to the fan. This is my fan remote control. See, cannot. Okay. Now you will see the light. You can see the light. It's blocked already. But if I don't block, then can. So infrared is very easy to be blocked. So don't use infrared. Short distance, okay. Okay, short distance, okay. Long distance, don't use infrared. Yeah, very easy to be blocked. Yeah. So you just try this with your phone camera. Any remote control will do. Now find out you can't see with your bare eye, but you can see through your camera. I should give you this, huh? Okay. Why no response? Okay, and for this one, jangan. Yeah, jangan. You just see. Okay, so this one looks shallow. This one looks shallow too, but it's deep. So we say it's apparent depth. And always remember the depth count from surface to the bottom. Okay, surface to the bottom. Surface to the bottom. Okay, the height count from the bottom to the surface. So this is depth, this is height. But here they give height. I don't know why. They should use depth from the surface to the bottom. Okay. So if in exam you write D over small d, can or not? Cannot. Okay, now 1 over f equals to 1 over u plus 1 over v. So now, and oh yeah, one more. Power of the lens equals to 1 over f in meter. Okay. If you close it up, can you redo? Close and redo. Okay, for Tulip already tried this. But can you close your answer and redo on the side? If you can do it by yourself, then shows you already understand it. Okay, now info is what? Info is focal length of convex lens 20 cm. So 20 cm. This is F. What is the power of the lens? Power of the lens is yeah, correct. So this is in meter. You need to change in meter. 0.2 meter. So formula given or not? Sorry, not given. So power equals to 1 over F in meter. Okay, so formula power equals to 1 over F in meter. So power equals to 1 over 0.2. Answer. The equal weight is 5. Power is what unit? Power using diopter, D. The unit of power is diopter, D. Okay. Okay, now convex lens, F always positive, but concave lens, focal always negative. Why? Because concave lens, we use the F in front, negative. Because the light is supposed to pass through the lens. So after the lens, yes, it's positive. Okay, convex positive, concave negative. How to remember? You remember the exact convex. If you twist it, it will become positive. Okay, so remember in this way lah, convex lens, positive. The X, you twist it, convex lens always positive. Okay, then concave always negative lah. So the focal length of concave lens is 10 cm, negative 10 cm. So what is the power? Change to negative 0.1 meter. Power, don't know. Power equals to 1 over F equals to 1 over 0.1. So answer is 10 diopter, negative 10 diopter. Negative 10 diopter. Okay, so when you have higher power of lens, means you have shorter focal length. That's why you cannot see further object. Further object means far object. Further. Alright, so now the diagram shows the position of image of an object formed by convex lens. Convex lens. Find the height of image. So what information can we get here? What information can we get here? For example, 30 cm is what? Object to the lens. So 30 cm is what? Is U. Very good. Thank you, Grace. Okay, then 9 cm is what? What of object? Oh, HO. Yeah, thank you. HO, height of object. Then height of image, don't know. It doesn't tell. H. Then now, can you please tell me what is V? Thank you, Bethany. V, those now. Yeah, V means from image to the optical center of the lens. So U actually is 10. Sorry. V equals to 10. So find the image, height of image, so we can check back our formula. Only got V over U. So you add one more, HI over HO. So V over U equals to HI over HO. So we substitute. V is 10, U is 30, HI over HO. And actually from here we can know the results already. Further will be bigger. Shorter V would be smaller. So HI equals to, let's multiply sin 3 cm. Why 4.5? 4.5. 3 cm. 3 cm. You cross multiply 9. That's random. Okay. Yeah, too early in Sunday. I know. Okay, so now the object of height 8 cm is placed 20 cm from concave lens. Concave lens. So this one you all do it now. Okay, so okay, so this one linear magnification equals to V over U, and also equals to HI over HO. Since they give two height, object height HO, image height HI. So we can directly use HI over HO lah. HI 2, HO 8. So we will get 1 over 4. Please make it as decimal places. Then what is the image distance? V over U equals to HI over HO. Since V we don't know, U is 20 cm away from it. If you want, you can make 20 cm. Oh, sorry, no need. So HI over HR is 1 over 4. So V equals to 5. V equals to 5 cm. Or if you want, usually you can say the U is negative 20, the V is negative 5, means before. So like this, this is negative 20, this is negative 5. Okay. So next. Now, the formation of the image is shown in the diagram. If image distance is 4 cm, so image distance is 4 cm. Before the lens, it's negative. Focal length is 10 cm, also negative. Focal length also negative 10. Okay. Calculate the object distance. U equals to how much? So since we have VUF, we want U. So we can use this formula. 1 over F equals 1 over U plus 1 over V. So we say 1 over F equals to 1 over U plus 1 over V. Because all form in front of the concave lens, in front means before. So if you put all negative, can you don't put negative also can. So 1 over F is 1 over negative 10 equals to 1 over U plus 1 over negative 4. So we move this to another side, plus minus minus, so it will be 1 over 4 minus 1 over 10. Then just press calculator. Why F negative? Because if we use the F after the lens, positive. But now it's diverging light. So we use the F in front of the focus point. So it's negative F. Yeah, very good. Any question from us? Okay, so you will get yeah, calculator. Okay, 0.15的。I'm sorry, I think I did something wrong. Oh, I didn't did something wrong. I forgot. Yes, 6.6667. I forgot to change. So 1/4 minus 1/10, we will get 3/20 equals to 1/u. Just now I forgot. This is a careless mistake lah. So now how to get u? We use u equals to 1/, we just change the place of 3/20. 1 divided by 3/20. 1 divided by answer. I would like to do this 1 divided by answer. Answer is 3/20. 3/20, then we will get 1. So you use, since you get this as your answer, so you say 1 divided by answer. 1 divided by answer, you will get 6.6667 cm. Okay, my Anissa. Yeah, 1/10 is negative. Yeah, and positive, negative, negative. Put here positive. Because both of them in front of the lens. So negative, negative. Right? Right, so these two do together. You do right. Okay, fast position of image form. So we got info height 5 cm actually is height of height of object. Place 12 cm from convex lens. X, the X you twist a bit, it's positive F. Okay, so positive F is 12. Sorry. 12 cm is object distance. Object is placed from X and focal length is 4 cm. 4 cm is focal length. Convex positive. Determine the position of the image form. So V equals to don't know. Okay. So what formula should we use? We got 2. 1 is this. V over U equals to HI over HO. Another one is this 1 of F equals to 1 of U plus 1 of V. Which one would we use? I mean, number 5 or number 7? Yeah, number 7. Why? Because we don't have type of image. We don't have yet. So we use number 7. 1 over F equals to 1 over V plus 1 over U. 1 over U plus 1 over V. Why sorry? Why sorry, number 5, correct? Correct. If we use number 7, cannot because we don't have information about I and O. So cannot use it. So we use numbers 5. Since we got FUV, linear magnification 就是它放大多少倍，它放大还是缩小多少倍 ？It is a ratio. Okay, so we say 1 over 4 equals to 1 over 12 plus 1 over V. So 1 over V actually is 1 over 4 minus 1 over 12. So 1 over V equals to 432，所以2 over 12乘3乘3减1分。Then what should we do? We say V equals to 1 over 2, 1 divided by 2 over 12. So V equals to, we just balik them, 12 over 2 means V equals to 6 cm. 对吗？你先减出来1/4减12/1，然后溢出 answer. So this is 1 divided by answer. You get the answer first, so 1 divided by answer very fast. Then what is the characteristic of image form? So since U is 12 cm, V is 6 cm, so from here can we know image magnify or diminish? Magnify 放大 diminish 缩小 Yeah, very good. Actually from U and V we can know already. The image diminish. Characteristics. Okay, one more. Image diminish and what do you think? The image is real or virtual? Upright or inverted? Okay, so if you're not sure, let's draw. Principal axis. Okay, then we draw F. Focal point force, focal length 4 cm. U is 12, means 2F is 8 cm. So actually U is behind 2F. Behind 2F. So KFC. So we will get the virtual. Yeah. 12 cm means F 4 cm, 2F, 8 cm, Ligy 4 cm, further away, very far away from F and 2F. Principal axis, F agak the same, 2F agak the same. In exam, please use ruler to measure F and 2F. Then U is very far away. U is Ligy 4 cm from 2F, 12 cm. Then draw A, F, C. And you'll find out your image is here. So we say image terbalik loh, because the intersect part is the tip. The light comes from the tip, 这个尖角, the tip. So it will intersect on the tip too. So this is inverted. Since it's been inverted, sure, it's real. Nothing. 只要它 inverted 到法，它就是 real. Okay, real means after the lens. Image, real means image form after the lens. 为什么？因为 lens is transparent, so the light supposed pass through the lens. Pass through the lens. So normally inverted means real. Okay, now this one based on the graph. What is the focal length of the lens used? So we use 1 over F equals to 1 over U plus 1 over V. Okay, now here got the confusing part. Here got the confusing part. A, 1 over F equals to 1 over 0.05 plus 1 over 0.05. B, 1 over F equals to Hi Haris, 0.05 plus 0.05. Which one is correct substitution? A or B? A 1 volt, B 1 volt, or B 2 volts. Fast. Okay, children, thank you. Angel, thank you. Beside for tulip life, where are others? B. Yeah, correct. Actually, it's B. A wrong. A wrong. Why? Because from the graph, 0.05 actually is 1 over V. Okay, from the graph. Then 0.05 actually is 1 over U. Okay, so we just directly say 1 over U, 0.05, 1 over V, 0.05. Done. So this one is when the graph like this, VU, 0.05, 0.05. From the graph, if they say this is V, okay, then only you substitute the V and U. But here, is 1 over V equals to 0.05. Substitute all. Alright, so now we will get 0.1. So F equals to, press calculator, 1 divided by answer. Your answer is 0.1. So answer is 10 cm. 10 cm. 1 over v is not 0 at x-axis. Yeah, correct. But when 1 over u is 0, 1 over v is 0.05. So actually, the gradient here, the gradient of the graph is 1 over f. Okay, so the gradient of the graph is gradient of the graph means y changes of y over changes of x. So it's 0.05 divided by 0.05, and you will get 1. Wait, we ignore this one. Okay, so this one, please do it yourself. Number 8, do it yourself. Okay, now optical instrument. So now this is we join two lenses. For what? For telescope and microscope. Telescope 望远镜 microscope 放大镜 microscope 放大镜 okay? Okay, so if you want to magnify the image, we always put object in between, not in between. This is F, this is U. We always put U smaller than F, 放大镜 okay? 放大镜 So, magnifying lens consists of a single lens. So, if you want to make the object larger, we put object in between O and F, means U smaller than. Alright, so now, this is microscope, but we look at telescope first. Oh, microscope. Sorry. Page 209. 209. Okay, so normally, microscope and telescope got eyepiece, means our eye look at this lens. Both of them has eyepiece. Our eyes look at this lens. Okay, telescope. No matter telescope or microscope, telescope. Okay, telescope normally like this, I got two lenses, right? Microscope also got two lenses. One is eyepiece, one is objective lens. Okay, so both of them got one objective lens. Objective lens means we take the light from object. Okay. Okay, but first of all, when we use microscope, we will have two lenses. So for microscope, we will put the object in between two FO, means objective lens, two objective lens. So we say U is bigger than F objective, but smaller than F2F objective, because we want to make the image real. So we enlarge one times here, KFC. So now we get a real image. See, inverted one, inverted. Then we use our eyepiece to do one more time KFC. But now you can terbalik your book. 1, 2, terbalik your book. Now, the first image will become object for eyepiece. So I need to terbalik your book. So this is image. Then what should we draw? Let's draw KFC one more time. KFC. Then you will find out I cannot converge. So we extrapolate. Become second image. So we are using two lenses to enlarge, to magnify the object twice. This is original object. We magnify once by objective lens, and we enlarge second time for eyepiece. Correct? Eyepiece. Okay, so that's why normally the distance between, so actually the distance between objective lens and eyepiece, for this case, we say L. L is bigger than FO, focus length for objective lens, plus FE, focus length of eyepiece. Okay. Now, next. Okay, so now, what is the linear magnification for microscope? This is old type microscope, not old type, the classic type microscope we call compound microscope. We still got electronic microscope, and what else? The electronic microscope. That one we use digital to enlarge. So the magnification for this microscope is MO times ME. Okay, MO times ME. Then what is MO? MO means height of image 1 divided by height of object. Then what is ME? ME is height of image 2 divided by height of image 1. So actually we got how many arrow? We got 1, 2, 3. So let's say here is HO, our original object. Then it will form image number 1. Image 1. Then we use eyepiece. When we use eyepiece, this image 1 will become object for eyepiece. Then we will get another image, H2. So MO is H1 over HO. M1 is equals to H2 over H1. Amen. This object form this image. Amen. This object form this image. Then now this image become object of eyepiece. Okay, so now we need to magnify this object for eyepiece. So this is H2. So magnification got one time, original and H1. Then second time, image divided by this object. Okay. So H1 divided by H2. Second time, H2 divided by H1. Okay, never mind. So now, this is not given. This is not given in exam. But I never see this in exam before. I never see this in exam. Okay, now this one, objective lens, because we want to see object far, far, far away. So we use FKC. FKC. So we will get object under the focus. Then we use KFC. We use KFC. Then we will enlarge the object. We'll enlarge object in infinity. Okay, so magnification twice. Okay, telescope, this is telescope. Telescope. This is telescope. So the telescope will collect light from far away. So we use FKC. And we magnify the first image. Okay, so the L is equals to FO plus FE. Okay, seems like you understand. Okay, so actually M equals to PE over P1. This one in minus. Yeah. So you all please complete 209 to 10. 209 to 10. Just copy the answer and you read out. Right? And 211. Okay. And before you go, maybe we can do this page 50, 55. 55, you do it yourself. And 56. And 6.2 for 56, page 56. Page 56. This is microscope, simple microscope. So We are required to determine the most suitable microscope to see tiny object clearly. Okay, so what kind of lens you use? Concave or convex? Or convex? You can see microscope, telescope, all convex. All convex. Yeah, thank you. Convex. Focal length of eyepiece. Focal length of objective lens and focal length for eyepiece. This is objective lens. This is eyepiece. Okay, obviously these two out Thailand. You get out already. So only here. Which one will have longer focal length? Let's check. Microscope. Longer focal length. Eyepiece will have longer focal length. Okay, from microscope. So eyepiece will have longer focal length. Okay, this one. Distance between two lenses must be bigger. L bigger than FO plus FE. L bigger than FO plus FE. Power of eyepiece should be high. High power of eyepiece means low focal length. Sorry. Not only low focal length. High power means you can magnify larger. Magnify larger. Okay, answer is R. Okay, you can check answer. What's the reason? Okay, so finish all of this lah. When you are free next week, when your BM or BI done already, you bring this to school and always do it. Okay, behind your answer can check. It's exam practice lah, right? Okay, thank you everyone. Bye. Thank you everyone. Bye. Yeah.